I'm going to try and respond to a question I got at lunch just to repeat some of this work, and then I'm going to ask Karen, if she's just finished speaking, for special permission to use her example 2. So example 2 I find completely straightforward in an LR framework, and I would use every locus in it. And I thought I might just expose myself to the criticism of the audience or convince you how easy it is, one or the other. So I'm allowed to walk now. I've got a microphone, and that's very much my preferred approach. The question during the lunch break was, could I repeat some of what I did in very tiny font here? I'd gone a little fast and had lost some of the audience, so I'll have a little go at that. And I also had admitted to say I was dealing with a 2-person mixture. Now, I actually haven't had the usual questions I get, which is, how do I feel about making assumptions of the number of contributors? We can go there if you want. I'm taking the number of contributors a lot less seriously nowadays than I used to. We're at a 15-plex at the moment, and it's quite hard for a 3 to masquerade as a 2. But let's imagine we have something like this: A, B, C, D, and at every other locus it looks like a 2-person mixture. Up front I say I'm dealing with it as a 2-person mixture, and we explicitly write that. How many different sets of 2 people can make this up? I know this is a repeat for most of you, but just wander along with me. You can have an AB and a CD, an AC and a BD, and an AD and a BC. And there's 3 of those. And just for funsies, I'm going to carry on. You could have a CD and an AB, and we notice that's the mirror image of that one, right? So I'm not going to bother putting them in now, but each of those guys up there has a mirror image. That one's a heterozygote, and we've historically written that as 2PQ, so I'll put the 2's in. That's a 2 in, and they are swappable, so there's another combination. That's a 2, and so on. 2, 2, 2, 2, 2, 2, and that tallies 24. So there are 24 combinations of alleles that make that up. Now, you might have noticed I swapped smoothly from people to alleles. So there are 2 combinations of alleles that make up an AB, right? There's AB and BA. All right. I know you all know where 2PQ came from, but I'll just tell you. You've got Buckleton's buckets. I did not name these, all right? 2 little buckets here. These are places I can put alleles, all right? I got an A from Dad and a B from Mum. I'm an AB. Or I got a B from Dad and an A from Mum. An OR in words is a plus in maths. An OR in words is a plus in maths, all right? A from Dad and a B from Mum, or a B from Dad and an A from Mum equals 2 FA, FB. And you've just seen me derive Hardy-Weinberg's law. That's actually how they did it, all right? Okay, and I didn't let you go to lunch until you'd done the other one. I've just got the slight suspicion some of you snuck off without getting the answer. A, B, C, C. Now we could write this one out, and okay, let's do that, shall we? All right. Now Chris McGuire got up there and said he can never remember, right? There's some little mind tricks I've got. So there's the het hom, A, B, C, C. All right, het hom, right? A, C, B, B, B. So I've just memorized there are 3 het hom combos. All right, now you got the hets, so A, B, A, C, and that's like the double A. A, B, B, C. So it's double A, double B, double C. All right, het hom, het hom, het hom, het, 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 het. It's just how I remember it. All right. There's a 2 there and they're swappable. Total of 4. There's a 2 there and they're swappable. Total of 4. There's a 2 there and they're swappable. Total of 4. 2. 2 and they're swappable. Total of 8. 2, 2 and they're swappable. Total of 8. 2, 2 and they're swappable. Total of 8. All right, that's how you do it if you're not using my little formula. All right, now if Karen would give me just the kindest permission to use her example. I don't know how you can say no now, you're sort of cornered, aren't you? But you know, you told me you wanted to do some real ones, so let me see if I can do this. You know, I'm having a small failure here. You might find me screaming for help in a minute. In fact, now. I actually thought Karen's example was a really good example for what I believe in. Can we get down to example 2, which is probably back up, isn't it? I should be all right now, I think. You know, I feel there's something sort of rude and intrusive about going into someone else's talk. So I thought I can use this one to make 1,000 different really good points. As I understand it, this is on the outside of a suspect's shorts. And as I understand it, the major profile appears to match the suspect. So I don't know what the story is, but I'm going to assume this is a sexual assault case, and the allegation is that he's raped someone, and that this DNA on him, on his shorts, is a mixture of him and the victim. I don't know, but that's what it sort of sounds like to me, all right? Because we're not so surprised to find the DNA of a man on his own shorts. That's not really particularly at question. So I've historically used these terms HP and HD for the 2 hypotheses. P stands for the prosecution and D for the defense. I've had a bit of criticism about using P and D, so I've actually given it and gone to 1 and 2, but let's go with P and D. I think the prosecution alleged that this mixture is a mixture of the suspect and the victim. All right? Now, the defense don't have to say anything. There is no obligation in the adversarial system for the defense to actually say anything. So I see it as our responsibility to make the most reasonable hypothesis for them. And they are not going to say that it's the victim. Remember, this is on his shorts, and it's the victim's DNA on his shorts that counts, all right? But they're at complete liberty to say S. So I'm going to say S and U, where U stands for unknown. Now, as a general principle, it is in the defense's interests to concede the DNA of anyone consistent with innocence, and it is clearly consistent to concede the suspect's DNA on his own shorts. And I hate to admit it, I bet my DNA's on the front of my shirt. All right? All right. I don't know. I won't bore you doing all these loci, but do any of them look particularly hard? Karen, if I go forward, do I get the reference profiles? I don't know, let's do D3, all right? So, this is a mixture of the suspect and the victim, right? We're allowed to assume what's behind the bar is true. If that's a mixture of the suspect and the victim, I would see 14, 16, 17. All right? So that happens with probability 1. If that's the mixture of the suspect and an unknown, right? The suspect contributes the 14. The unknown has to be the 16, 17. Okay, I'm going to use the product rule. I don't believe in the product rule, but I'm going to. all right? So we're going to go 2 f of 16, f of 17. Okay, I would actually have something else there, but let's not get there, all right? That's D3, and I can do that in my head, all right? Because, you know, I've been told LRs are so hard that you need PhD in maths to do them, or perhaps like Mark Perlin, 3 PhDs in maths. Are any of these really hard? So let's do one with a red in it. I actually think P into D is straightforward. So let's do that. I find that absolutely straightforward. So if that's a mix of the suspect and the victim, I do indeed expect 10, 12, 13, 14, all right? If that's a mixture of the suspect and someone else, okay, the suspect accounts for the 12, 14, the someone else has to be 10, 13. All right, 2 f of 10, f of 13. All right, I think there's, we can go to one slightly harder. Hardest locus I can see there is CSF1PO. All right. If that is a mixture of the suspect and the victim, I would see 9, 10, 12. Please, someone stand up and yell no if you don't believe me. The other thing I should tell you is I'm massively error prone. I just make mistakes all the time. So if you see me write something utterly stupid up there, please at least bear in mind the possibility it's me. All right? Under HD, it's the suspect and someone else. So the suspect's going to sort the 10, 12. What is the someone else? So he's definitely got a 9, right? We know that 9 is there, but we're not sure what the other allele is. I saw some really good nods. In America, do you call that 9X? Call it 9X. Have never called an X in their life. Really like calling it F because that's what the POMs do. Okay, we're sticking with F. The true offender is 9F. Now look, I've been putting that in curly brackets. Just cruise with me, I'm inventing a nomenclature. When you are age 20 and you go to school, they teach you a nomenclature. When you're age 30, you apply it. When you get to my age, I'm not going to tell you what that is. You're allowed to just start inventing them. All right, so I'm inventing a nomenclature for this. The way to do this is 9F. How many orders of the letters of the symbols 9 and F are there? Well, I'm going to do it the slow way for you. You can see there's 2, right? But let's do it. It's 2 factorial over the number of 9s. 1 factorial, 1 factorial. Do we agree that's 2? Okay. I'm just leaving my curly brackets in. F. I nearly went American. All right. Now, the trick is get the number in and lose the F, and there's your formula. Now, I don't want Bill leaping up out of his seat. I've just used the 2P rule. I've done a bit of cheating. I'm about to prove to you what all my cheating was. Is there a non-concordance? No, I don't believe there is. The suspect doesn't have an allele not visualized. So my binary model is safe. No non-concordance. Binary model safe. 2P rule safe. This is safe. I don't care that that allele's red. All right? I find that, I would find that profile straightforward. And I'd use every locus. I also, without creating any contention whatsoever, would like to say I completely approve of looking at this mixture, saying it's too complex and closing down instantly. All right, so I actually quite liked, I wouldn't use quite the words Todd Bill used. He said, you can't make a chicken salad out of something else. You know, the sentiment in that is really spot on. Debbie, I hate to say it, I might need rescue again. Oh, okay, thank you. I've missed it. If I have one, I'm stuffed. Do you have that word in America? Okay, the moment I've got one, my binary method breaks, okay? But let's play the game. Where's FGA? There's a non-concordance in there. 1921. So indeed, you're right, the 19 is non-concordant, okay? So what do? My binary system breaks down. I need to look at that 21. It's actually not even red, is it? So I guess it must be above 150. So I'm deeply concerned about that locus, right? That one, thank you for pointing it out, that one actually brings me to my knees with the binary model, okay? I have to deal with that locus using my D model, and can I tell you the likelihood ratio for that would be a very small number? Remember, 1 is neutral, small numbers support the defense, and when I work the math through on that, which we can do now if you want, we'll save that one, shall we? We'll work the math through on that towards the end of this course. I'll get a likelihood ratio of like, I don't know, 1 in 100 or something. It's going to knock it down. What's the lesson? Ignoring that locus is not safe. Right? That actually is tending pretty strongly to exclusion, that locus. I saw some nods, all right? I actually realized Stephen, who I was accusing of being replicate shopper, Stephen, he came up to me and said, I'm not a replicate shopper, you know. I knew that, you know, I was using him as a straw man. Turns out when I saw his surname, Stephen and I have been in correspondence for about 10 years as Stephen, and I think I've quoted you a few times in my book, and so Stephen's been, he's looking at me really blankly, he hasn't read my book, you know. All right, look, I will undertake to do locus FGA, and I'm going to try and get a likelihood ratio well below 1, so supporting the defense, right? The rest of this profile might drag it through, but that one's a worrying locus, all right? Thank you. So I've sort of just done this. I've just done examples exactly. Oh, yes, please.
Does the non-concordance or D model still apply to that, knowing that it's more prone to dropout?
Sure. So just to repeat that, we're going to go back to FGA, which I did promise to come back to later, but we'll do it right now. FGA is a high molecular weight locus and therefore more prone to dropout. But my understanding of Karen's slide is that the 21 allele was quite big because it was black. I don't know what, I think from memory that would have meant it was above 150, Karen? So the question is, even at FGA, can you have a heterozygote with something above 150 and the other not visualized? Yes, please. You know, was it? Which one was in the stutter position, the 20? The 21 might have been built up by stutter, so can you all hold all that? Because that's a really good practical one. Yeah, I know I'm trying to fend you off because I want to just get a block more theory into you, but you're all doing the probability of dropout in your head, right? Those of you who are saying the 21 might be built up a bit, right? So the true 21 might be lower, so the probability of dropout might be higher, all right? Let's try and do that mathematically rather than in your head. Should I also confess about this time that I'm about to get rid of the stochastic threshold? I know. Who's clapping? Was there? Okay. Yeah, I've been quite challenged by you as an audience, which is nice. And I don't know if you read the literature and see Bruce Bedoldi and I having a big old scrap, but when you go to probabilistic models, that stochastic threshold goes, it just gets replaced with the probability of dropout, and you stop having to make these arbitrary decisions. You know, I actually see us doing little contortions to make things work. You know, if it's got a red allele in it, you can't use the locus. If it's, you know, I consider these contortions, and it's because our core underlying structure isn't right. It's my belief. All right. Back to where I am. Push out of the binary model. I believe it's in its last stages. I'm going to teach you how to do likelihood ratios for n-person mixtures, where n can be 17 if you feel like it. Now, if I ever catch you doing a 4 or more person mixture, I'm going to set Todd Bill onto you. Because you cannot make chicken salad out of chicken dung, all right? The mathematics works for anything, but you still need to have your brain on because you can't make chicken salad out of chicken shit. All right. So this is a 2-person mixture. I have 3 peaks showing. Reasonable hypotheses are suspect and unknown versus 2 unknowns. The suspect is AB. If HP is true, the unknown is CF, all right? I'll just put them in curly brackets. It's actually, I'm calling them allelic vectors, right? Little curly brackets for vectors. If the suspect is not a contributor, there are 2 contributors, unknown. What are they? Well, I don't know, but they've got the alleles A, B, C, and F. Okay? All right. You're going to like that. It's going to be good. It's going to be good. It's going to be good. If not, you can have a coffee. Okay. How many orders of the letters C and F are there? 2. All right? 2, curly bracket C, F. How many orders of the letters A, B, C, and F are there? I don't expect you to know that right now. The answer is 24, all right? Let's work it out. There are 4 symbols there, right? There's 1A, 1B, 1C, and 1F. 4 factorial is 1 factorial is 1, right? So that's 24, curly brackets, A, B, C, F. Once you've got the number in, you can lose the F. A 2 and a 24 go as 12. A C and a C cancel, right? You've never seen anyone do cancellations inside curly brackets before, have you? Right, 1 over 12, F of A, F of B. And you've just done the likelihood ratio for that locus. All right? Now, with that technology, you are now unleashed to do anything. I've got one more little dirty trick to teach you, but this technology will allow you to write down the likelihood ratio for anything. Now, again, please don't. Sure. Three. Sure, absolutely. In fact, not only is it possible, it is likely. Can I? Sure. So in the great stack of jobs for me to do, can we do the FGA problem and the number of contributors problem? All right? And if you want, I know what the main defense things are because I've been doing this a while. So I claim I've just shown you how to write down a likelihood ratio for anything. I told you I've got one more trick left. Is it timely for me just one more time to say, please don't just do it for anything? All right. Now I want to show you why I'm allowed to do that. So what have I told you to do? Put in the number, cross out the F. Why are you entitled to do that? Here's my proof. Now, up the top it says, please don't concentrate. I do not anticipate testing you on this today. Okay, but it turns out that with a little bit of effort, we can demonstrate that that approach always returns a conservative answer, right? It's actually wasting some information. And I might, if I get time, show you what it's wasting. But, and remember, I don't like waste, right? So I'm doing something I don't like here, right? But, you know, okay, there's the proper way to do it. So that thing down there is the actual answer, all right, at the bottom. And I can tell you that 1 over 12 AB, I'm going to walk over there, all right? If you have some sort of absolute magic thing, you can see that that 2 and that 2, those are very similar, those two equations, all right? That whole thing in the square brackets, the 2 minus, and that 2 minus is very similar. That thing is approximately 1 over that, and this is always conservative. Can you believe me for a minute? All right? So, put in the F's, work out the number, cross out the F's, do some cancellations, you've got a likelihood ratio. And that's what that says. It wastes a bit of evidence. I'm going to see if Todd comes up to me in the break and says, I've worked out what bit it wastes, because he's noticed this. Put in the F's, work out the numbers, do the cancellations, there you go. All right? So I've got one last trick I told you, and that's just in writing out these allelic arrays. And I was fed last night that you guys want to get into some really hard ones. So this one looks hard enough to me. Okay, now, can you just blank out my words for a minute and just look at that little tiny snippet of an EPG? So what can we say about that profile before? Can you blank out those words? I wish I'd constructed the slide better. Can you focus on the profile and ignore my words, please? What can we see? Well, unfortunately, the little bit I've cut out, we can't really see the heights, but we can see we have a 12, 13, 14, and 17, relatively minor, but above 50, all right? We have a 19 that's either a stutter or not, and we have a considerably bigger 20. All right, is that some sort of description of what we can see there? All right, now let's imagine that the rest of this profile looks like 3 people. I'm going to deal with this as 3 people. I want to write down the allelic vector, all right? Remember, I write these down in curly brackets. Do we agree that we can see a 12, which I'll write as an 11 because I'm stupid, 13, 14, and 17. Now, how many 20s are there? Thank you. That is so good. I've got stuck at this point, and you just got straight there. So there are at least 2, right? If this is a 3-person mixture, all right, how many alleles in total do I expect? 6. So there's at least 2, and there's not 3. So that is the allelic vector. Can we agree that is actually the allelic vector for that? I'm not saying who goes with what, right? I'm sure as not hell saying the 13 goes with the 14, but there are 3 people who between them have that. Do I need to do that again? Because that is an indispensable fact of logic, which you got in 5 nanoseconds. Okay? I'm happy, we can just do these forever. Okay, person of interest, I'm gonna, I don't know, I don't actually care, but let's make him a 12, 13. Okay? If one person, so HP is person of interest plus 2 unknowns, right? HD, 3 unknowns. Are you all sort of okay with my little shorthand? Because it's pretty bad, really. But okay, if the person of interest is in there, the other 2 people have to account for, curly brackets, 14, 17, 20, 20. All right? Cool. And no one's known, so it's the whole job, right? 12, 13, 14, 17, 20, 20. LR is, I'm not going to tell you now. What's the number in front of that? Little aside, right? Little micro aside here, right? 4 factorial over how many 14s are there? 1? 1 17, 2 20s. 4 factorial over that is 12. Okay, LR is 12. F of 14, F of 17, F of 20, F of 20, all over. Here's a good one for you. I'll race you. You're allowed to use your calculators, which Debbie got you to bring, right? I think 6 factorial is 720, but I'm notoriously wrong, so please check me. Anyone get 360? Anyone get a number different from 360? Anyone not get a number? Anyone forget how to vote? You wait. Mike Coble is going to give you little voting buttons soon. And then we're going to know when you don't vote. All right? F of 12, F of 13, F of 14, F of 17, F of 20, F of 20. You don't need me to help you cancel that much.